is the office hours video for section 2, factoring and the zero product rule. So hopefully at this point you've had some practice manipulating symbols, and hopefully you're beginning to see that that's going to be a better way of thinking about things than thinking about things in terms of numbers. Now, when working algebraically with symbols, a lot of times you want to solve for one of the symbols, and a good way to do that is to factor the expression and use the zero product rule. So here's an example from the power required by some sort of semiconducting device. So if you go through the analysis, sometimes the power requirements go like the time used to the third power, so the time is cubed. And there are other factors involved also. Sometimes there might be a factor involving the time squared, and all that might be somehow related to some factor involving just the time. So after thinking about the physics, you might come up with something like this. And the question might be, at what time are these power requirements satisfied? So you want to solve this equation for t. And what a lot of people might be tempted to do is to just divide everything by t. But this is not a good idea, because when you divide an equation by one of the variables that you're solving for, you'll end up losing solutions. So the best thing to do is to rearrange the equation until everything is on one side, usually the left side, and all of that is set equal to 0. So I'm going to do that with this by just subtracting 6 times t from both sides. So now it's all equal to 0. And now what I want to do is factor that. Right away you can see that time is involved in all of them, so I'll factor that out. And what's left is t squared from the first term, t from the second term, and 6 from the third term. Now in the next section we're going to talk about the quadratic formula, which would be a way of solving for time in the parentheses. But at this point I want to just talk about factoring. So in order to factor this quadratic that's inside the parentheses, what I want to do is come up with two numbers that, when multiplied together, give -6, and when added together give -1. So the -6 is the constant term, and the -1 is what's multiplied by the term in the middle, in this case t. So two numbers that'll do that are -3 and +2. So if you try that, -3 times 2 is -6, and -3 plus 2 is -1. So if you work backwards and multiply these terms together, you'll see that you end up with what we started with. So now that we have everything completely factored, let me put an extra parentheses around the first term. We can use the zero product rule, which is also called the fundamental theorem of algebra. So it's a very important theorem, and basically says if you have a bunch of things that are multiplied together and set equal to 0, at least one of the things has to be 0 in order to get 0. But only one of them has to be 0. So we can just look at them one at a time. If I look at the first term that's multiplied, t is equal to 0. So these power requirements are met when you're right at the beginning, when the time is 0. And if you put that number back in to the original equation, 0 cubed minus 0 squared equals 6 times 0, you see it works. You get 0 equals 0. Now if we divide it through by t at the beginning, we would have lost that solution. No, that would not have been a good thing. If we look at the second term, t minus 3, that could also be 0. So if I add 3 to both sides, time would be 3. And the units we usually use for time are seconds. So I'll put those units down. 3 seconds after the start, the power requirements would be met. And then if I look at the third term, t plus 2 equals 0. And subtract 2 from both sides, we get this expression, t equals negative 2 seconds. Now that doesn't make a lot of sense. We turn the machine on at time t equals 0, so a negative solution for time, in most physics courses we would ignore that. We would ignore that solution, because time is usually greater than or equal to 0. So I'm going to go ahead and put a line through that one, because that solution's not realistic. So the final solution set for t greater than or equal to 0 for these power requirements are either right at the beginning, t equals 0, or 3 seconds later. So that's an example of factoring and the zero product rule. And as I mentioned, it's a much better way of solving an equation than dividing. Because if you divide through by things, then you lose information, you lose solutions, and that's not a good thing. In this case, we would have lost the fact that the power requirements were satisfied right when we turned the machine on at t equals 0. So please, when you see one of these relationships, make sure that you factor the expression completely and use the zero product rule, and that way you won't lose any solutions. So you might want to start maybe practicing on that. In the next section, we'll look at using the quadratic formula, and in the next office hour, we'll solve the same problem. We'll do some factoring, but use the quadratic formula to solve the expression that was in the parentheses before we factored it further. So you'll see that in the next section. See you then.